Hi all, I am Udit. Welcome back to my channel. I hope you all are doing well. So this video is actually about various components of system design. I've already done a similar video around 3-4 years back, but I thought of doing it again because the components have changed, the systems have changed, various new things have come up, and I thought, okay, I'll maybe do it in a little different way. So that's why I'm doing the similar video again. So today again we are going to talk about if you're going to design a new system today, then what all you need. I'm not going into the details of each of the component, like how it works, but overall I'm going to tell you various components that you would need whenever a system is going to be designed. I'll also tell you when you will need each component in which area, so that you can go into the details of them in your own time. Also, I'll try to create separate videos on different components. Some of them I've already created. You can check my YouTube channel. More I'll try to create in coming months. Now, before going into the actual content, I like to talk about my HLD course and my LLD courses also. So I've recently launched a HLD course where I'm going to talk about HLD from scratch in detail. We are going to start from very simple solution like single server, single database kind of a thing, and then we'll try to complicate it from there. We will try to understand when to introduce each technology, when not to introduce each technology. Everything I will be teaching about in that HLD cohort. It's going to be a small batch size cohort. So if you really want to join it, if you really want to understand HLD in detail right from scratch, you can join that cohort. I'll be putting the link of that in the description of the video. Also, if you are looking for LLD content, if you are also preparing for LLD interviews, I have done some cohorts whose recorded cohorts I'm also going to put in the description. In those cohorts also, what you will see, the content is right from scratch. We are solving each and every problem right from scratch, so that you get to know when to make a decision, how to make a decision, how to approach a problem, everything about it. So if you are really preparing for interviews and looking for some cohorts, I would highly recommend to join those, because everything is being taught right from scratch in those cohorts. With that, let's continue with today's video now. So let's start, right? And I'll take a very standard problem. Maybe let's say it's about Twitter. Okay, though the concept that I'm going to tell is applicable to all the problems, but let's take the example of Twitter. So let's say we are going to design Twitter today. So let's say this is the user, right? And when you have the user is going to make a request to the server, and generally the request first lands onto something called gateway. Okay, so the very first concept that you get is API gateway. Before even going to the API gateway, what happens is user types the URL in the browser, right? When a user types a URL in the browser, let's say you type twitter.com. Now the browser has to open twitter.com's homepage, right? So browser has to convert the domain to the IP, and for that they use DNS. This is called domain name service. So DNS resolution is something where a domain is converted to an API. So that's the very first step that happens when you type google.com in your browser. Once the IP is received, that IP is generally of the first landing server, which is maybe the gateway. I mean, in some cases it can be an S server, and also I'll talk about it when it is there, but let's assume it's the gateway for now. So first the request lands on the gateway, and on gateway you can do various stuff. You can do your SSL termination, you can do maybe API routing, right? You can do some DOS attacks solution. So the point is, API gateway is like a front facing thing for your service, whose job is to receive the first request from the client. And some people also do load balancing on it. I mean, it depends on you, but API gateway is the first concept that you will get, and you will do multiple things on top of it. Now, once the request comes to the API gateway, right, then if you're not doing load balancing on the API gateway, then the call will go to the load balancer of the service. And let's say it is the create tweets call, right? So create tweet call will come to the tweet service. So here it's a tweet service, and this is a microservice in the system. Okay, so what do we call it? It's a microservice. Before coming to the actual service, the call goes to the load balancer, as I said, and load balancer work is it tries to distribute the request to the various servers. Like one request will be there and there will be various servers. So load balancer will pick which of the servers to use, and there are various load balancing algorithms which are there. Depending on what algorithm you have configured, load balancer will pick that particular server, and the request will go to that particular server. Now after the request is has reached the server, then it goes to the database, right? Now databases can be of various types. It can be a SQL database, right? Like MySQL. It can be a Postgres also. Postgres is also a SQL based database, right? It can be a NoSQL database also. NoSQL database is like, okay, you have Mongo in the system, you have Cassandra. There are a bunch of NoSQL databases these days, right? So basically point is that the tweet is going to be stored in some system, which is going to be a database. I mean, you call it DB, right? And once the data reaches DB, I mean, you can have various types of databases, as I said, SQL versus NoSQL. When to use SQL, when not to use NoSQL, I have already created a separate video on it. I'll maybe put a link of that in the description, or maybe you can search it on my YouTube channel. But the call goes to the database. So this is like a create flow. Various systems got used when we were trying to use the create flow of a Twitter system, right? Now, let's say if you are going to build a feed, right? When you're going to build a feed for a user, again, I'll not talk about how we are making those decisions and all that. Maybe we'll try to cover in some other video, or you can join that cohort. But if you want to build a feed, then the standard solution, which you might have seen elsewhere also, is that you will use a queue here. Okay, this is another component of the system. Is something is called a queue. Now, what is a queue? Queue is like it's, as the name suggests, here the data passes one by one, and queue can be of two types. One is like a normal queue, like SQS, right? And another one can be a topic-based queue, like SNS or Kafka, right? So basically, the differences between them is, as the name says, normal queue is just like single queue, messages come in and one by one they just consumed by the consumers. While the topic-based queue, here there can be various subscribers, right? And whenever a message is published onto a topic, each of the subscriber will get the message. That's the difference between a normal queue versus a topic-based queue. So in normal queue, there is only a single subscriber, but it can have multiple consumers of its own, right? In a topic-based queue, there can be multiple subscribers. There is subscriber 1, subscriber 2, and now each subscriber can have multiple consumers, C1, C2, C3, C4, C5, C6, right? So yeah, I mean, whenever you're trying to do something async, or you're trying to fan out things, then you use a queue. If you're just having async situation, then you will use a normal queue. If you have a fan out kind of a situation, then you will use a topic based queue, because multiple subscribers can be there in that case. Now once the subscriber gets it, it will be a consumer, and that consumer will consume and store the data. Now once the consumer has got the data, right, now again the data is going to be stored in a DB. So the DB's choices remain the same. I mean, you can have a SQL DB, NoSQL DB, and lots of other stuff. I'll not go into the details of them. Talking about another system, right? Let's say we are going to also build a top K hashtags in the Twitter itself. So again, the top K hashtag, what it will do, top K hashtag will also get the message from the queue itself, isn't it? Now top K hashtag will sort of, what it will do, it will try to run a job, right? So there will be a cron scheduler, right? And that cron scheduler, it will try to sort of compute the top K things every hour or every day or something like that, and it will be putting that data in something called a cache. Okay, and whenever user is trying to find the data back, it will get the data from the cache. So there is something called a cache that lies in the system, and popular caches are something is like Redis, you might have seen. Now let's talk about something called partitioning. Okay, now all the databases that we have seen, SQL, MySQL, and Redis, even Kafka is like a data store. It's a persistent queue. All of these actually have something called partitioning. Okay, partitioning can be of two types. One is horizontal, second is vertical. Horizontal partitioning is also called as sharding. You implement sharding by using consistent hashing. Okay. I mean, you can implement sharding without consistent hashing also, because consistent hashing has its downside also, though benefits are more, but it has its downside also. But yeah, consistent hashing is a popular algorithm. I think you should learn about it. But yeah, partitioning is a very common concept in databases whenever you are trying to scale your system. Similarly, another common concept in databases is replication. Okay. Actually, before going to the replication, one more very common concept in sharding actually is called shard key. So you should learn about it. There's something called shard key and there's something called sort key. You should also learn about global indexes in NoSQL databases or in partition things. And there's something also called local indexes. All of these things, I mean, sharding and all don't exist in MySQL or, SQL based database. That's why those concepts are not applicable over there. But here in NoSQL systems like, Mongo, Cassandra, also in Redis and all, these concepts apply. I mean, queues and all don't have those indexes. Similarly, Redis does not have indexes. But yeah, partitioning generally, you have to think about all of these things when you're thinking about partition. As I said, there is another concept called replication. Replication can be active replication. It can be a passive replication. And passive replication, has its own pros and cons again, it can be, it can have some delays, right? And that's why active and passive, they both lead to different level of consistencies. One is called strong and another one is called eventual. Right? So I think you have to learn about these concepts also. Then other than this, like there is different consensus algorithms, which are applicable for application, or maybe you can say availability in general. And those consensus algorithms generally come into play, like if some server goes down, then which servers to be made as the leader or made as the primary server and all. So I think there is something called Raft, Paxos and all. There are multiple algorithms for it. I would suggest you should read about them also. So yeah, so far what we have covered the, I think, basic systems. Since we are in storages, I'll talk about little bit more about storages. Okay, we have already covered SQL. I mean, we have already covered databases in SQL and MySQL. We have also covered caches and queues. Two more types of storage actually exist. So let's start with the use cases again. So where were we? We were saying user, is going to make a tweet. I'm just simplifying the whole process. And then somebody is storing in the DB, right? Now let's talk about another scenario. Let's say you have to store the image that, user is also allowed to upload image or a video in the tweet. Now when the user does that, you have to keep the image and video somewhere, right? So generally the system that you will use for that is, let's say there is a asset service, right? Now that asset service will have a special database called S3. We can use S3 from AWS. You can use, blob storage from Azure, or there can be a number of, cloud. So this is actually a cloud file storage system. Okay, it's like a system which is storing the file just like a blob. You can also do it in database, but again there are pros and cons. Database will be more costlier than using S3 for a for a blob kind of a system, like if you have to store video, image, all of those things where you don't have to query the content of the system of the data, then you generally use S3 kind of a system because it's very cheap, right? Now S3, as I said, it's a cloud file storage where you can store full-fledged files onto the cloud. Now when you are using S3, there are two concepts you should really understand. One is called direct upload. Another one is called direct download. It's important to understand because it's very much useful when you're using S3 and you're trying to implement a system using it. One more concept, related to this system is whenever you have something like, assets or, large files like videos, audios, or maybe bigger files, then storing them in S3 is ideal way, but you don't serve them always from the S3 or the actual data center where the data is stored. Rather, there is something called content delivery network. This is called CDN. CDN are like X servers which allow you to keep the data very close to the user, so that whenever you're fetching large amount of data, the amount of data which is traveling across the network is minimal, because you are trying to fetch it directly from the from another server which is very close to the user. Again, to understand it more, go into the details of it. But CDN is a very common server which many apps like YouTube, Netflix, even if I have to store videos or photos in Twitter, I'll still use CDN in there. So CDN is another system that you should learn about. A very common CDN is called CloudFront. There are various kind of CDNs available. Their job is to keep the data closer to the user. Hotstar, YouTube, all of these systems use CDNs. So yeah, after the CDN, I think, and S3, I think this is about the cloud file storage system. Yeah, another kind of a configuration system that I can think of is called Zookeeper. Okay, Zookeeper is not like an actual storage system. It's like more like a config storage. Okay, so whenever you are storing some configuration about the servers, okay, generally you will use Zookeeper. Again, you can read more about Zookeeper. Kafka uses Zookeeper very, commonly. Lots of systems use Zookeeper very commonly, right? One more kind of system to store data is called, which is also popular these days, is called time series DB. Okay, let's try to understand the use case of it. So again, let's say if we are creating a dashboard, when I say dashboard, meaning to the users or to the admins of Twitter, where we are showing how many tweets are being posted per second, how many comments are being posted per second, how many views are coming in for Twitter, per second or per day or per month, per week, meaning whatever. Whenever we are doing some analytics, right, and you have a data which is time series, meaning which is distributed over time, it's per month, per year, per XYZ duration, right? Whenever you have such kind of data, then it's easy, or it's, I would say, more efficient to store the data in a time series DB. Prometheus you might have used when you are when you might have implemented analytics in your own system. You put Grafana on top of it and all of those things you do to do time series analysis, right? The time series database are more suitable for problems where you have time series systems. So I think this is about the time series. And if you are going to implement the time series problem, then actually you will not directly make a call from tweet to time series DB in case of Twitter. Rather, what you would do, you will actually there will be again a job, right? There will be a views store, let's say, right? Again, whatever I'm designing right now, it's like a generic system. Actual system of Twitter or any other place where you're designing might differ. I'm taking a common example how commonly it would be designed without thinking about too much nuances, because my goal right now is not to design the better system, rather to tell you about various components that are there in a system design, right? So let's say there is a database which is storing the views. Now you will run a job, because it's going to be I would say a little high processing operation. So maybe you will use a MapReduce, EMR, like Spark and all you will use right here, kind of jobs, right, which will take views from here and put the data in the DB, which is going to be a time series DB, right? So far you with me? So far so much components you have understood so far. So that's about it. Now moving further, if I have to do some kind of a location based thing, right? Let's say if I want to send notifications to the user which are nearby to me, right? Then what I will do, the tweet service again will put into Kafka, right? It was like a Kafka which we were using earlier, and let's say there was a nearby notification service, right? Like I want to send notification to the users who are nearby to me, right? Now for that there's something called a quad tree that you can use. Quad tree actually is nothing but keep dividing the whole region into 4 quadrants, or you can use geohashing generally, right? Again, depending on various reasons, you can choose between the two. Sometimes you don't even need them. You can you can solve a problem without using them also. So again, I would highly recommend you to go into the details of them so that you understand each and everything about them in detail, right? Going further, right, let's say when a user is connecting with the app, with a service, right, then what kind of a connection is it? There can be 2 kind of connections. One is called REST API, meaning there can be 2 kind of APIs actually, and then connection is going to be TCP only, right? You are not going to use UDP connection here because you don't want to lose your packet. So connection is TCP. There can be 2 kind of APIs. One can be REST API, another one can be WebSocket based API. Okay. WebSocket you use in case of two requirements. One requirement is when you want to send server-side events, and second thing is when you want to make a persistent connection. When you have high number of input requests, in that case you use WebSocket kind of a system, so that you don't have to make connection again and again. But rather, if you don't have a such kind of use case, then you can use REST HTTP APIs, REST-based HTTP APIs, and here again the pros and cons are different. You can learn more about them in detail as and when you go. But yeah, these are the two kind of APIs then you will implement. Another thing that I want to talk about is about metrics, right? Whenever you are doing you're building a system, you want to be operationally good, you want to set up some things so that you can operationally analyze your system whether it is going good or not. So for that you generally use metrics, you use logging. You try to keep pushing metrics and logging to your systems, and those systems are generally they are called CloudWatch. Again, these is like a time series based systems, but you can read more about them. CloudWatch is AWS offering. You can have New Relic, it's a full-fledged company itself. You can have Splunk. So there's something called Datadog also, and you try to put metrics on various things like error rate, like number of requests, your latencies, right? And latencies you also try to put metrics on various things like P90, P95, P99, P50 also, maybe average latency, maybe maximum latency, maybe minimum latency. So depending on what kind of latency you're looking at, you try to put a metric on it. You also try to put metrics on some infrastructure things like CPU, memory, network IO, or lots of things you try to put metrics on, and many times actually these are given out of the box by the cloud infrastructure that you're using. Like for example, if you're using EC2 and all, then you will get them out of the box. Yeah, I think this is about the metrics. One more thing actually you do in metrics and operations is you put alarms, okay? Because you cannot go and check every now and then what's going on with the system. So that's why you put an alarm. You say if the system goes in a bad situation, and you try to define that bad situation, maybe like error rate go above 90%, latencies go above 5 seconds, whatever you think is beyond for you is beyond SLA. For that you try to put an alarm, and whenever that gets triggered, you get a really an alarm on your phone or on an email and all. So this is about the matrix. Another thing that you can use whenever you are trying to implement a serverless system, right? So there you can use something like lambdas, or you can call them Azure functions. In Azure you call them Azure functions, and lambdas in AWS it's called lambdas. So whenever you try to implement something like serverless, lambda is nothing but you can run your code in a serverless manner. You don't have to implement infrastructure, you don't have to manage any server and all. You just write your function code and it gets implemented. You can run on the basis of an API call, or as the trigger to an event. Lots of things you can do here. Another thing, whenever you're doing deployments, right? So the different technologies that you use for, it's called CICD, continuous integration, continuous deployment. So you use something like a Git, you use something like branches, you use something like pipelines, right? And again, pipelines differ a lot. In one system I was using it called pipeline. You might have heard about it. It's code deploy. You might have heard in AWS, right? So in different systems it's called differently. Then deployments can be different types. It can be blue-green deployment, blue-green, right? It can be progressive deployments, right? Then during deployments, feature flag is something which is important, so you should read about them. How do you do do continuous deployment, which is backward compatible? So generally you try to use feature flag with it. You can also learn about canary deployment, right? You should also try to learn about integration testing that you put in your CI/CD. You should also learn about load testing. Before sending something to the production, you do load testing, right? So once the testing is done and your system is in production, so after production you try to monitor your system just like we did, like using operations. So I think this is at high level, very common systems that you will use when you are doing a high level design. Obviously there are a lot more systems that can be there, like Yugabyte DB, Skylar DB. There are lots of DBs that keep coming in. But the point is, you cannot learn infinite things, right? But the major core concepts remain these, where system starts from the user's request, services, databases, cache, queues, those kind of things come in picture. And these are the more prominent things that you should definitely learn first before your HLD interview, because these are very common things which are going to be used in most of the systems. As you can see, we just tried to build a simple Twitter clone today, without thinking too much about the design, but we try to think about what all systems we will use for different areas. So yeah, I think that's all from my side for this video. I hope you like it and you got to learn something from it. Please do put a like on the video. Please do subscribe to the channel if you have not done already. Also, please try to comment for the maybe improvement areas or anything that is coming to your mind. And as I said, if you are interested in learning HLD right from scratch, and in detail understanding you want to get for each of the system that we discussed today, along with solving many practical problems, then please register on the cohort. I'm going to put the link in the description. I hope I'll see you in the cohort, or maybe I'll see you in the next video. Till then, bye bye, take care.